I don't know about you, but it seems like we're kind of flying through these things, huh? Like it. It's a good clip. Okay, let's talk about what's going down on the Gulf Coast. So as North America, as we turn our attention to more the southern end, that's kind of separating away from what is now South America, during the Triassic and Jurassic, the Gulf of Mexico began to form, with oceanic waters kind of flowing into this area that's being kind of extended and pulled apart as these plates are moving away from each other. It created some shallow, restricted basins where there wasn't a lot of too much in and outflow of water. Whatever water got in there just kind of got trapped. So conditions were really ideal for evaporate formation, as just this oceanic water that got trapped in these shallow basins, the water just evaporated away, left behind salt and other evaporate deposits. So let's keep an eye on this area down here. You'll see as South America is moving away and stretching away, we get the Gulf of Mexico beginning to form. This is Africa. The pull away of Africa more so had an effect on the East Coast. The pull away of what is now South America had more effect on the southern Gulf Coast. In the Gulf Coast region, there's more than 1,000 meters. That's a kilometer. That's 0.7 miles thick of evaporites were kind of precipitated out of the salty seawater. And they created these structures called salt domes, which are found in the Gulf of Mexico and southern Louisiana today. And by the later part of the Jurassic, which is the middle period in the Mesozoic, circulation in the Gulf of Mexico was less restricted. So you're starting to get currents and ocean water moving in and out, so evaporate deposits ended. So here is kind of what these salt domes are. So sometimes when you have these layers of salt, minerally known as halite, it is less dense than the sediment that builds up and rocks that build up on top of it. And since it's less dense, it wants to rise, just like a hot air balloon. Hot air is less dense than cold air. So when you heat up air in a hot air balloon, it's less dense. It wants to rise in comparison to the more dense surrounding cooler air. The same thing here. You get this less dense salt layer that wants to kind of rise up, and if it can make its way through some cracks, through some faults, and any way that it can, it will start to kind of dome up and create these salt domes. Excuse me. One thing about salt domes, they also are good traps for oil and natural gas. So this is why there are so many, oil and natural gas deposits in the Gulf of Mexico. Also in and around the Gulf of Mexico, reefs were widespread during more so the Cretaceous period, as we're ending the Mesozoic in this area. A type of bivalve, these kind of seashell-looking things called rudists, were common in the Gulf Coast region, and they were the main constituent of many of the reefs in the area. Because rudists, the shells themselves have a high porosity and permeability, meaning it's easy for stuff to kind of get into and out of that material. These types of reefs make excellent petroleum reserves. So again, further adding on petroleum areas in the Gulf Coast. So because of these salt domes, because of reefs that later could trap oil and natural gas, the Gulf Coast region has a lot of oil and natural gas exploration. So keep an eye on this area, especially in and around Texas, Louisiana. So these areas are all very high producers of oil because of, for example, reef systems like this. So as there was a subtle transgressive event as the water coming in, covering the shallows of the continent. Warm, shallow ocean water is what reefs need to survive. So that was created as we kind of move through the Cretaceous. Okay? All right. Again, just zipping through. So let's we talked about the middle of the continent. We talked about the East Coast. We talked about the southern Gulf Coast. Now let's make our way over to the west and talk about some western uplift. See you back here in just a second.